aren't they just the best? Thrills and shrills, foods that are fried, it's all outside, and all the joyride. And not to mention the best part, roller coasters. So what takes us from this to this on the most exciting part of theme parks? Well, it all comes down to physics. So in this video, we are going to go over some of the super cool physics of roller coasters that are so interesting it would even make Sir Isaac Newton's head spin. So there's a few different terms we're going to be going over, but first we're going to start off with force. What is force? Force is a push or a pull that causes motion, and there's multiple types of motion. There's move, change of direction, or change of shape. The next term is potential energy. Potential energy is the energy held by an object because of its position relative to other objects. An object possesses gravitational potential energy if it is positioned at a height above the zero height. This is a really important concept to keep in mind when it comes to roller coasters. Just keep imagining that really steep hill you always go up at the beginning of a roller coaster. The next term is kinetic energy, which is the energy of mass in motion. The kinetic energy of an object is the energy it has because of its motion. So now let's take a look at an example of potential and kinetic energy in action. So in this example, our alien friend is up 3 steps, which gives his potential energy a bit of a boost for throwing the planet. As he throws the planet, that is the kinetic energy, and that's how far it goes. So what if we put him up even higher? What would happen to the kinetic energy? So we see his potential energy is now even higher, and he's going to throw the planet, and the kinetic energy, we will see the planet goes even further. So now what about with roller coasters? How does that work? So the purpose of the initial ascent is to build up a sort of reservoir of potential energy. The potential energy you build going up the hill can be released as kinetic energy, the energy of motion that takes you down the hill. Potential energy is affected by mass, gravity, and height. Gravity applies a constant downward force, and the tracks serve to channel this force. So if the tracks go downward and gravity pulls them down, it accelerates. So with a combination of potential energy, kinetic energy, gravity, inertia, acceleration, centripetal forces, and g-forces, roller coasters are a thrill to ride. So we can't go to the theme park today, so why don't we build our own theme park at home and test out some of these awesome physics concepts. So for this challenge, you will need paper, a printer, scissors, a marble, tape, and some space. So Mamie is planning out her paper roller coaster with a template she found online. And you can find that by just Googling paper roller coaster. So you can see that she is cutting her paper roller coaster out and is going to show us how to create a loop. So this is going to take a little bit of time and some planning, but I promise you it's worth it. And now it's time to see potential and kinetic energy in action. Mamie starts her marble up top, which gives it a high potential energy. And you can see that the kinetic energy is released as it goes down the track. Let's see it a few more times. Now let's add the extra challenge of a loop and see if we have enough potential energy to make it happen. So Mamie increased the height of where she started her marble, which increased the potential energy, which released enough kinetic energy to make it through the loop. So now it's your turn to try this challenge out. If you do the challenge, please take a picture or a video and tag us on Facebook or Instagram. Thank you!